Hi everyone, in the previous video we talked about the 4 different points on the curve and how we are supposed to calculate 3 different points on the curve in our syllabus. Right, so how should we go about calculating them? Alright, what we can do is by understanding what is present in this solution. So I know I've mentioned this quite a number of times, but this is actually a very crucial concept. So we realize that at point number 1, what we have is just ethanoic acid. At point number 2, what we have is the buffer solution where we have the acid and also its conjugate base. And number 3, at point number 3, we only have its conjugate base. And so typically for questions like that, since we are talking about weak base, we are usually given the value of this Ka. Alright, so we are going to look at these 3 different parts and find out how we can answer such questions. Okay, so now what we want to do is to reframe our question. Right now, what we want to say is that when we have point number 1, what we are essentially doing is taking the weak acid and throwing it into water, and that's all. And we want to see how it actually dissociates. So since this is an equilibrium question, we know that HA is going to dissociate to H plus and A minus. So the so the ice table should show you this. Alright, so HA, let's say this starts with 0.1, this is 0 and 0. When you add it into water, it will dissociate minus x plus x plus x. So you get 0.1 minus x, x and x over here. So what you will notice is that if you want to calculate the value of, if you use the equation for Ka, you'll get x times x over 0.1 minus x. And we usually say that the dissociation is to such a small extent that we can approximate this to 0.1. So that's why this is equal to x squared over 0.1, and whatever Ka value you have over here can be used. So to find the concentration of H plus, which is x, alright, we have to take the square root of Ka multiplied by 0.1. So this is where the main issue comes that a lot of students face, because they are so used to learning this equation that they just plug in the value into the equation without knowing what is going on. So you can only use this equation if the acid is only added to water and there's nothing else in the solution. Alright, this is purely the dissociation of the acid. So if you realize why can we use x squared is because there's only x here and it started with 0. So if I have a little bit of A minus or the conjugate base present, I will not be able to use this equation. So the best way is always to go back to the equilibrium ice table and solve it. Okay, so with this, then once I have my H plus, I just take the negative log of H plus. I will be able to get the pH of the solution. So this should be quite straightforward. So the next thing that I'm going to talk about, I'm going to skip number 2 first. I'm going to talk about point number 3. So once again, at that point in time, we only have the conjugate base. So we pretend that we take the conjugate base and stuff it into water right now. And what we'll notice is that this conjugate base, alright, will react with water, alright, to give us our acid plus OH minus. Okay, so I'm going to remove this so that things become clearer. So I hope this looks like a B minus plus H2O, right, which gives us a BH plus OH minus. So if we were to write the expression, since this acts as a base, this will be Kb BH over times OH minus over B minus. So we omit this H2O because this is a heterogeneous equilibrium. We only include the aqueous substances, not the liquid state over here. Okay, so based on this, what you'll realize is that we can if we draw the ice table. Okay, let me just shift this away. Okay, if we draw the ice table, right, initial change equilibrium, I should have by that point in time, since my volume has already doubled, Okay, so volume already double. So I would have 40 cm cube of that, so my concentration would have half. If you don't understand what I mean, you can go and work out those things again. So what I have is that initially I have 0.05 moles per dm cube of that. So water, I'm not interested in them. So I had 0 of this, 0 of this. Okay, now I throw into water, I'll lose some, gain some over here. So x 0.05 minus x. So my kb is actually equal to x squared over 0.05 minus x, and since this dissociation is weak, this x is negligible, so it's equal to x squared over 0.05. So for us to find, we can actually use this to find the concentration of OH minus and then convert them to POH and then convert it to pH. But the question is this, how do we then get this value of Kb? Because once we get the value of Kb, we will be able to solve for the whole question. And this is where a very powerful relationship comes in, right? Where Kw is equal to Ka times Kb. Notice this equation only holds when you are talking about the weak acid and its conjugate base, so the acid conjugate base pair. Alright, so this is the only time you can use this Kw is equal to Ka times Kb. So since this is a fixed value at a given temperature, you are given this in the question, you can use that to find Kb. So this procedure is very it's quite repetitive. So once you get it once, practice it a few times, and you will always be able to get that. But ultimately, the question that you need to ask yourself is what is present at that point in time. Okay, so we don't care about whether the equilibrium has occurred or not. We are interested in the point where, let's say, it's the initial amount. How is it going to change? Okay, so notice I bring back my ice table again. Right, so after I mix everything in, I treat it as the new initial. There is no we haven't formed these two yet, and then after that, through the change and the equilibrium, we'll know what it is. Alright, so this is what we call step 3 is what we call the salt hydrolysis. Okay, so this is what we have looked at, and now let's take a look at the final portion here, number 2. Right, so since we know that this is our buffer solution, alright, so all we need to do is to bring in the Henderson-Hasselbalch equation, use the new concentration for both of these, and then we will be able to get the answer. Alright, so just substitute the values in, and it is as simple as that. But one trick for you to take note, alright, when you are answering buffer questions with the Henderson-Hasselbalch equation, it is always a good practice to convert everything to amounts first. Because when you add two solutions together, the volume will always change, so the concentration is constantly changing, but the amount stays the same regardless of the volume of the solution. So always convert to amount first before converting back to concentration. Okay, so let me write this down here. Right, very important part. Please remember this very carefully. You have to find the new amount, new volume, then you use that to calculate the new concentration. Right, only when you're very confident can you work with concentrations immediately, but to be safe, try to use amount and volume instead. So I hope that this past 2 videos, alright, has helped you to understand this chapter better.